The theme of the conference has been Beyond Biogas. How does your work fit with that theme?
So we're interested in how we can use molecular tools to dissect the community interactions that are happening in anaerobic digestion, and I think that's a really good way of making anaerobic digestion more efficient. By understanding the communities, we can potentially start to intervene and make them better at what they do, and long term we can potentially rather than go all the way to biogas, take the carbon that those organisms are manipulating and turn them into other higher value products.
I really like the topic of beyond biogas because that actually we are moving into as the solar energy and the wind energy as renewable sources have become cheaper. We have to look in the biomass as a new type of a new resource which have to be prioritized in the best way. So heat and electricity can be left to windmill or solar, and we can use biomass in more advanced ways as we are looking at the moment, like filling in the gaps or going to more advanced high value products, looking in the best clever way to use biomass.
Whatever works for biogas will work for all other biological systems now and all the ones we're going to invent in the future. In fact, by understanding how the biogas systems works, we get a body of universal knowledge we can apply to make many other technologies in the future.
What I'm involved in is a pilot plant which is looking at what we call in situ biomethanation, which is converting hydrogen from electrolysis with carbon dioxide from anaerobic digestion to make methane, but using the same bugs which exist within a working anaerobic digester, because hydrogen is an intermediate product of anaerobic digestion, the bugs are there already.
One of the things that we've been fighting is the perspective that energy in the future will involve no combustion whatsoever, that it will be turbines and everything will be electricity. What I liked about today is that biogas really fits into the circular economy. There are waste streams that have to be treated, there are slurries, there are brewery wastes, and the gas that's produced is a fantastic vector, an energy vector. And what we have found is that if you look at energy consumption anywhere, typically electricity is about 25%. There's roughly 40% for transport and 40% for heat. So a lot of the talks this morning were about breweries and creameries. They are huge users of gas. And a lot of these breweries and distilleries want to be carbon neutral. So there's a demand for renewable gas, for green gas. So we would see a huge area in that. If we have biogas and we put it into the gas grid, it can be sold immediately to a distillery, or it can be sold to a bus company. And the topics that are spoken about here today are quite important because we're looking about biological upgrading. So using electricity, when there's too much electricity, to produce hydrogen, to upgrade biogas, put into the gas grid, and you now have an advanced biofuel.
We, until now, considered biogas something at a smaller scale, related with wastes, just kind of treating wastes which otherwise would be a very big problem. We can do a lot in terms of alternative energy, green energy, but we can also do, and that is the new part, a lot in terms of CO2 captation, CO2 upgrading, and in recycling, making the nutrients recycling in a proper and a clean way. Until now, the nitrogen and the phosphorus came out in the digestate. I'm bringing the message that we should recycle the nitrogen and the phosphorus through mechanisms which bring them beyond any criticism from the regulator. We can do that. We can integrate all of that in the concept of the biorefinery driven and based on anaerobic digestion. And that's a great perspective which has lots of implementations in terms of our discussions with politicians and government in relation to the climate change demands which were agreed upon in Paris.